Resistors, the most ubiquitous of electronic components. They are a critical piece in just about every circuit. And they also play a major role in our soon-to-become favorite equation, Ohm's law. So in this course we will cover what is a resistor, resistor units, resistor circuit symbol, types of resistors, finding a resistor's power rating, resistor composition, and last but not least, decoding the color bands. So let's get started. So what does a resistor look like? Well, all resistors have two terminals, one connection on each end of the resistor. When modeled on a schematic, a resistor will show up as one of these two symbols. The first symbol is an American style 1 kilo ohm resistor, and the second one is an international style 47 kilo ohm resistor. The terminals of the resistor, as you can see here, are each of the lines extending from the squiggle or rectangle shape. These are what connect to the rest of the circuit. The resistor circuit symbols are usually enhanced with both resistance value and the name, as you can see here. So the value displayed in ohms is obviously critical for both evaluating and actually constructing the circuit. And on the other hand, the name of the resistor is usually an R preceding a number. So each resistor in a circuit should have a unique name and number, right? For example, here's a few resistors in action on a 555 timer circuit. In this circuit, resistors play a key role in setting the frequency of the 555 timer's output. Another resistor, R3, limits the current through the LED. Of course, you don't have to know how this circuit works right now, because we didn't even learn about integrated circuits, but I just wanted to show you some resistors in action. In the previous course, we mentioned at the moment that the size of conductors, fuses, and the components themselves will determine how much current will flow through the circuit. That's 100% true. Conductors and fuses can determine the current in a circuit, but as you will realize, their significance in changing the current will highly decrease when there is a resistor present in the circuit. So let's just first define what a resistor is. Resistors are electronic components which have a specific never-changing electrical resistance. The resistor's resistance limits the flow of electrons through a circuit. We already know that current flow is nothing else but the flow of electrons, right? So resistors are electronic components that are used to limit or set the current in a given circuit. Why do you think this component got the name of resistor? Well, they literally resist the flow of electrons. In electronics, and it's important for you to remember this, electrical components can be either passive or active. Throughout the course, we will have the chance to play with plenty of electrical components, and you need to know which component in which category falls. So as I mentioned, there are two categories. The first one is the passive devices, and the second one is active devices. Briefly, components incapable of controlling current by means of another electrical signal are called as passive devices. So resistors, capacitors, inductors, transformers are all considered passive devices. On the other hand, an active device is any type of circuit component with the ability to electrically control electric charge flow. So active devices are like transistors, power sources, vacuum tubes, diodes, integrated circuits, etc. And we enumerated a lot of electrical components here, but we don't know yet what a resistor is. As you might already know, the electrical resistance of a resistor is measured in ohms. The symbol for an ohm is the Greek capital omega letter. You don't have to memorize this, but the definition of 1 ohm is the resistance between 2 points where 1 volt of applied potential energy will push 1 ampere of current. And we will define Ohm's law, you will see why. Larger or smaller values of ohms can be matched with a prefix like kilo, mega or giga to make large values easier to read, right? It's very common to see resistors in the kilo ohm and mega ohm range, much less common to see milliohm resistors. For example, a 4700 ohm resistor is equivalent to a 4.7 kilo ohm resistor, and a 5,600,000 ohm resistor can be written as 5.600 kilo ohm, or more conveniently as 5.6 mega ohm. Just like any electrical component, resistors will come in one of two termination types. The first one is through hole and the second one is surface mount. These type of resistors are usually abbreviated as either PTH, which comes from plated through-hole, or SMD or SMT, which comes from surface mount technology or device. So through-hole resistors come with long, pliable leads which can be stuck into a breadboard or hand soldered into a prototyping board or printed circuit board. These resistors are usually more useful in breadboarding, prototyping, or in any case where you would rather not solder tiny little 0.6 mm long SMD resistors. The long leads usually require trimming, and these resistors are bound to take up much more space than their surface mount counterparts. SMD resistors come in standardized sizes, usually either 0807, 0603 or 0402. They are great for mass circuit board production or in designs where space is a precious commodity. Just be aware of the fact that if you want to work with SMD resistors, you need to have a kind of precise hand to manually solder them. We could talk a lot about why should someone use through-hole instead of SMT. Well, overall, through-hole components can withstand more environmental stress, and that's the reason why through-hole technology is commonly used in military and aerospace products that may experience extreme acceleration, collisions, or high temperatures, right? Also, the through-hole resistors, since they are bigger in size, they can usually withstand more current than their counterpart SMD resistors. The key difference between SMT and through-hole mounting area, the SMT does not require holes to be drilled through a PCB, and SMT components are much smaller and can be mounted on both sides of the board. The ability to fit a higher number of small components on a PCB has allowed for much denser, higher performing and smaller PCBs. On the other hand, the size of the package also tells you an approximation of how much current it can handle. A resistor's power rating can usually be deduced, as I mentioned, by observing its package size. So standard through-hole resistors usually come with 0.25 watts or 0.5 watts ratings, and more special purpose power resistors might actually list their power ratings on the resistor. Now let's talk briefly about the resistor composition. Well, resistors can be constructed out of a variety of materials, and the most common modern resistors are made out of either carbon, metal, or metal oxide film. The carbon composition resistors are very small in size and have less power loss. Also, the resistors can have a very high value, even up to few mega ohms. These are so small that we cannot even indicate the value with readable digits on it. And for that, we use color codes on the resistor body to indicate the resistance value. Now you might be wondering how to find out the resistance of a resistor. Well, the easiest way is to measure it with a multimeter, placing the two probes in parallel with the resistor leads. This is usually the most preferred way, but cool engineers can read the value of the resistor by decoding the color bands. So through-hole axial resistors usually use the color band system to display their value. And most of these resistors will have 4 bands of color circling the resistors, though you will also find 5-band and 6-band resistors. In the standard 4-band resistor, the first 2 bands indicate the 2 most significant digits of the resistor's value. The third band is a weight value, which multiplies the 2 significant digits by a power of 10. And the final band indicates the tolerance of the resistor. The tolerance explains how much more or less the actual resistance of the resistor can be compared to what its nominal value is. No resistors is made to perfection, and different manufacturing processes will result in better or worse tolerances. For example, a 1 kilo ohm resistor with 5% tolerance can actually be anywhere between 0.95 kilo ohm and 1.05 kilo ohm. So how do you tell which band is first or last? Well, that's a good question. The last tolerance band is often clearly separated from the value bands, and usually it will either be silver or gold. If you want to know more about decoding the color bands, here's a very nice image that clearly shows the purpose of each band for resistors starting with 4 bands, 5 band and 6 band.